Hello everyone, welcome back to my channel once again. As you can see on the screen, we are learning in this video chemical symbols and formulae. So what do they mean? Think of where you might have seen these symbols outside of the classroom. About like MgCl2H2O Fe plus 3 CH10, CH4H10. Okay, you can comment where you can see them. Now today you will learn how to represent elements using chemical symbols and also understand the basics of IUPAC nomenclature in naming compounds and also use of chemical formulae to represent compounds. So now, did you know about Swedish scientist Johannes Jacob Berzelius introduced the modern system of chemical symbols? He represented the elements using one or two letters from their Latin names. So let's see one by one. Now first of all you need to know what is chemical symbols. These are shorthand ways, that is shortcut to writing the names of the chemicals to represent elements in chemistry. Here you can see an example, that is sodium, which has Na is the short form of it. Okay, and whenever we are writing the name of the chemical or elements, we are writing always the first letter should be capital and the remaining will be small letters. So each symbol is made up of one or two letters. Recall that an element cannot be broken down into simpler substances. Okay, we have learned this in another video. Now, importance of chemical symbols. Why we have to give them symbols? They provide standardized ways of representing elements, making communicating information about elements and compounds easier. Okay, otherwise whenever we are writing reactions, we have to write entire name of that chemical or element. That's why this is the way to represent the chemical reactions. So they offer a concise and simple way to represent elements in chemical equations, eliminating the need to spell each element's name. Sometimes you need to just means write a spelling, but you cannot write every and each element spelling. Okay, now let's see some common chemical symbols. Hydrogen derived from the Greek word that is hydro and genes, which means water forming. Okay, which means water forming, and this is most abundant element in the universe. Next is oxygen. Names comes from the Greek that is oxy and genes, which means acid forming. Okay, hydrogen is the water forming and oxygen is the acid forming, and this is essential for life. Now next is the carbon, derived from Latin carbo, that means charcoal. Okay, it means charcoal, and charcoal we can found in any life forms. All the life forms, wherever the living thing is there, that contains carbon. Now more are there. Nitrogen, which comes from the Greek nitron and genes, meaning the nitre forming, and it constitutes about 78% of Earth's atmosphere. It is present in the atmosphere. Okay, at what percent? 78%. Now next is the sodium, just we saw, that is having symbol Na, derived from the Latin natrium. That's why they took Na from the natrium, and this is a soft metal that easily tarnishes when exposed to air. Tarnishes means get destroyed. Okay, when we are exposing to the air. Okay, it is very flammable in nature. Now next is the chlorine, name derived from the Greek that is chloros, which means greenish yellow color. It has greenish yellow color, widely used in disinfectants and cleaning products. Now here is the game symbol Scrabble. How many elements can you recognize from the chemical symbol below? Okay, and you can just pause this video and you can just identify the names of them, and when you unpause you will get the answers. See here. Now symbol Scrabble. Okay, these are the answer for the previous slide. Au is nothing but gold, then Ni is for nickel, magnesium is Mg, iodine I, phosphorus P, silver Ag, then K potassium, calcium Ca, then Hg mercury, aluminum Al, zinc Zn, and carbon C. Now this is the periodic table where 118 chemical elements listed in this periodic table in a specific order. We will learn that in our another video of particularly on the periodic table. Now there are some rules on how to name these new elements in the periodic table are set up by the International Union of Pure and Applied Chemistry, that is IUPAC. Okay, they have just set up the rules how to name these elements. So the role of IUPAC is responsible for establishing unambiguous and consistent naming systems, also known as nomenclature and terminology. It has a system for naming chemical compound that provides a standard language for scientists worldwide. Now naming compounds. A compound is a substance. First of all, what is the compound? A compound is a substance that containing two or more elements that are chemically bonded. Here you can see the example, that is chemical formula for carbon dioxide is CO2. Okay, so what does the formula CO2 mean? It shows how many elements are there in the particular compound. A chemical formula is an expression showing the elements in a formula in a compound and their relative proportions. It contains combination of chemical symbols and numbers. You can see here in the example carbon dioxide, the symbols are carbon and oxygen is having two, okay, two atoms of oxygen. Let's understand again. Now carbon dioxide is a compound of carbon and oxygen, one carbon atom and two oxygen atoms because of the subscript 2. Here you can see the number 2, that means it shows there is presence of two oxygen atoms. Also we can show this molecular model of carbon dioxide in this way. Now naming ionic compounds. Okay, an ionic compound is composed of a metal and non-metal. Some of the basic rules when naming ionic compounds include ionic compounds formed by uh, replacing the replacing the ions. Okay, so here the first rule is a metal will always come first in the chemical formula and then followed by non-metal. Okay, first metal and then non-metal. Example is sodium chloride, that is NaCl. Here sodium is the metal and chlorine is the non-metal. Now an ionic compound with two elements will have a name that ends with ide. Copper sulfide in a previous example, sodium chloride, okay, ide, CuS. Then a compound with three elements including oxygen will have a name that ends with ate or ite. Sodium sulfate or copper sulfide, NaSO4, sodium sulfate. Whenever you can see the four atoms of oxygen, so it will become sulfate, and whenever you see the three atoms of oxygen, that will become sulfite. Now naming covalent compounds. Covalent compounds where the electrons are shared by the two elements, okay, to form a bond. Now covalent compound has two or more non-metals. Some of the general rules when naming covalent compounds are, so the non-metal furthest to the left on the periodic table comes first. Now here carbon dioxide, that is CO2, a covalent compound with two elements that will have a name that ends with ide, that is dioxide, that is SO2, and use the prefixes like mono, di, tetra, tri, that means mono means 1, di means 2, tri means 3, tetra means 4, to indicate the number of that element in the molecule. An example is given, CCl4, that is carbon tetrachloride. Naming covalent compounds, here is some more examples are there. Water, H2O, it has two hydrogen atom and one oxygen atom. In ammonia it has one nitrogen atom and three hydrogen atoms. And in CH4, that is methane, one carbon atom and four hydrogen atoms. Okay, so one more game is here. According to the names, you have to guess the chemical formula of them. Okay, let's see that. Okay, these are the answers for the previous slide. Potassium bromide, that is KBr, lithium iodide, that is LiI, then carbon monoxide, that is CO, sulfuric acid H2SO4, potassium nitrate KNO3. So in this way we have learnt about the chemical symbols and chemical names, how to give them names according to the IUPAC nomenclature. If you like my video, just subscribe and share my video to your friends and family. Thanks for watching.